While urban areas thrive with modern ICT advancement, rural communities often struggle with basic communication access. The digital divide is growing, leaving remote areas like Buayan, a village in East Malaysia, without the infrastructure needed for digital application. Hi everyone, I'm Tan Chong Eng, a professor from University Malaysia Sarawak. Our research tackled this gap by designing a small footprint off-grid system architecture tailored for rural environment. In remote rural, where network coverage is poor and power supply is unstable, our system combines sustainable energy with computing application under a single platform. And this solution not only enables the deployment of digital application, in this case, the cultural mapping system in the remote village, but also empower the community to protect their cultural heritage against external threats. Orders started from a small remote village in East Malaysia named Buayan. This Dusun village faces an urgent challenge. The preservation of its rich cultural heritage is at risk due to a proposed hydropower dam in the area. Despite being inhabited for generations, the record of the Dusun people's cultural asset is minimal and incomplete. To protect their heritage, the community needs a reliable way to document and store this critical information for community sustainability. However, implementing a cultural mapping system in Buayan is far from straightforward. The village relies on an inconsistent micro-hydro system, leading to unreliable electricity that threatens the stability of any digital solutions. Additionally, the village's remote locations make physical access difficult and expensive. And the local community has limited IT literacy, further complicating the adoption of any new technology. Those challenges demand a robust, sustainable ICT system architecture that can operate independently in this harsh environment, ensuring that the cultural mapping data is secure, always accessible, and manageable by the community itself. To address the challenges of deploying a cultural mapping system in remote rurals like Buayan, we have designed a new small footprint system architecture with aim to achieve both energy efficient and long-term sustainability. First, the system is highly efficient in power consumption. Using an IoT-based CPU controller that is extremely low power consumption, requires only 4 to 6 watts of power to operate. And this low energy demands allow us to use a smaller, more cost-effective power supply, including a renewable solar power system that can run the system 24/7. Second, the system is designed to be compact, making it easier to transport to remote locations such as Buayan. The solar power setup is minimal, with few 30 watts panel and a lead acid car battery, which can be easily replaced by the community every couple of years. After all, batteries are consumable items and they should be easily found everywhere, just like any car battery, for easy and economic replacement. Lastly, the software system is designed to be low maintenance, running on a Linux-based environment with automatic service management that would not fail even during unexpected system power outage. This ensures that the system is robust, self-sustaining, and required minimal technical support, which is crucial given the limited IT resources in the village. Overall, This integrated architecture not only powers the cultural mapping system reliably, but also create a self-sufficient ecosystem that supports the community needs. What set our works apart is the innovative system architecture, specifically tailored to overcome the unique challenges of rural communities. Building on our previous rural telecenter design, we have developed a solution that scales down power requirements while maintaining system reliability and ease of maintenance by the local community. The system architecture is not only more cost-effective, but also portable, which is crucial for deployment in remote areas like Boyan. We have minimized the power supply needs and designed a modular solar system that's both small and efficient, addressing the high costs typically associated with powering and transporting digital systems to rural areas. As we all know, the lack of stable and continuous power supply and tough road access are the two main factors restricting rural development. While traditional cloud computing isn't feasible due to limited network connectivity in remote rural areas, instead of hosting applications in the cloud, our innovative architecture bridges this digital gap by creating an integrated, self-sufficient platform to host applications locally. And more importantly, this system is maintainable by local community. This innovation has won the Intex 2023 Gold Award. And the system design also being published in Scopus Index International Journal of Advanced Computer Science and Application in 2022. And IP on copyright has also been filed in 2023 for this work. In conclusion, our innovative integrated small footprint off-grid system architecture has created a new avenue for digital system deployment in the remote rural area. Without depending on grid power and the internet, rural community can also enjoy the benefit brought by any digital application hosted locally within the community. Thank you for your attention.